So the thing I hear most about redox reactions is, what's the point? Because a lot of people can balance really simple equations just in their head, guys. But redox equations, or redox reactions, guys, actually tend to add a lot of complications to something that's extraordinarily simple otherwise. So to answer the question as to what's the point, guys, well, imagine that you have an equation like this, alright? Kind of like this. Alright, guys? And let's say that this produces something. Well, guys, chances are, considering how many elements or how many compounds there are, guys, you would have a hard time guessing this through. Right, guys? Well, that's where redox reactions comes in. Actually, guys, the Sharpie is really giving me a headache, so let's see if we can find a good marker. Or a better marker. There we go. Okay. So, what redox reactions would do, guys, in a circumstance like this, is to give you, let's say, a starting place, guys. Let's say that in all of this, there's only one compound, that's CD, for example, that changes oxidation states, guys. Alright? So, knowing how many CDs there are, guys, I can guess in the other equation how many C's and how many D's there are, right, guys? And going from that, I can go on to solve this ridiculously complex equation that I have no idea why I would try to solve in the first place, but which I'm solving anyways. Okay. So in an actual redox equation, guys, let's say, for example, guys, I have this relatively simple equation of CO plus diiodide pentoxide produces iodide gas plus carbon dioxide. Alright, guys? First things first, guys, is oxidation states, right? Now, oh snap, I just marked on my color. That's not gonna come out. Okay, well, first things first, guys. You know oxygen has this oxidation state of -2 most of the time, right, guys? So let's assume that this is a -2 here, alright? And we know that all of this has to have a charge of 0, right, guys? So going from that, guys, I can tell you pretty easily that since there are 5 oxygens which have a -2 oxidation number, then all in all, the oxygens have a charge of -10, right? And since oxygen have a -10 charge, guys, and I want the total charge to be 0, then iodine must have a positive 5 charge. 5. Right, guys? And now, looking at this as well, guys, you know oxygen has a -2 charge. Carbon, must therefore have a positive 2 charge, right? While over here, guys, you know this has a charge of 0. And carbon must have a charge of +4, because oxygen has a charge of -2, right? Alright, so I'm actually running out of time here, guys. So, really quickly, guys, half reaction-wise, to solve this, guys, I would have to look at first, let's say, what's losing electrons, guys, or what's getting a bigger charge, more positive charge, guys. Well, that's carbon, right? So, I can say C plus 2 produces C plus 4 plus 2 electrons, right, guys? Because if you look at this, guys, the carbon is losing 2 electrons, so the electrons go somewhere else, and they end up here. Alright? Well, for the reduction reaction, guys, or where it gains electrons, I would then have to use iodine, right? Because naturally, guys, it's the only compound, or the only element, I'd say, left. So, iodine plus 5 electrons produces that. Well, it's hold on. So, if you guys can scroll back just a bit, I plus, my 5 is really terrible today, I plus 5 E minus, or 5 electrons, produces iodine gas with a charge of 0. Right, guys? So, jeez, what was the other one? Hold on. C plus 2, okay. C plus 2 produces C plus 4 plus 2 minus. Okay. So, now guys, well actually, if you look at this, guys, we have one iodine here, but we have two iodines here. So really, guys, we just have to balance this out by making this 2 iodines and 10 electrons, right? Because I have to multiply this side by 2 to get the iodines equal to the number of iodines on this side. Okay. So, now we want to balance out electrons, guys. So we know we have 10 electrons up here, right? So we should multiply the bottom half by 5, right, guys? So that comes out as 5, 5, and 10. Right, guys? And so the original equation, guys, was CO plus I2O5 produces I2 plus CO2. Got squished. But, yeah, so we have 5 carbons on this side, right? So we just insert a 5 here, which is really terrible looking, but just bear with me, guys. 5 goes here, right, guys? 2 here, so I2O5, really? Oh, well then we didn't need to do that at all. Oh, but we're doing it anyways, okay. And 2 here, guys. If that made any sense at all, guys, because my battery is in fact just about to die. I hope this helps out with equations, guys. Alright? So, good luck on the test tomorrow, and see ya. Rank 1 out.